multi-programming. See, again I repeat, multi-programming is just a concept which says there are multiple processes or programs in the main memory. How do you define degree of multi-programming? Yes?
Number of processes that are waiting to be executed.
So basically that number, if I say that totally there are 5 processes in the main memory, I say that the degree of multi-programming is 5. So 5 is nothing but telling you the total number of processes in the main memory. So that is the definition of degree of multi-programming. Again, shortly I'll come to the significance of multi-programming, degree of multi-programming, and what does it depend on. Okay, students, before I continue, at the end of almost all lectures, I will be taking a test for you. Right, the test will last only for 3 to 4 minutes, and you'll have 8 questions. You are supposed to answer those 8 questions. They are MCQ, right? And your term work is based on how many marks you get in the test. So you have to pay attention. Whatever I am teaching in today's lecture, only the questions pertaining to that will be asked in the test. And students, please don't waste your time Googling for the answers, because if it is there on Google, it is not in my set. So make sure you all pay attention, and at the end, you all have to give the test. Your attendance will be marked based on the test. Any queries, students? Any queries?
No, ma'am.
Okay. So, coming to multi-programming. So, in a multi-programming system, there are a number of processes in the memory waiting to be executed by the CPU. Okay, in contrast, there is one more term called multiprocessing. What is multiprocessing? Though it's not relevant here, but just because multi-programming came up, I thought of covering that. Any guesses? What is multiprocessing?
Multiple processors work on the same program.
No. The concept multiprocessing means the system is having multiple processors. That's all. If there are n number of processors, then I say it's a multiprocessing environment. What is multi-programming? Multi-programming is a concept where more than one programs are there in the main memory. Multiprocessing is there are multiple processors in the system. So that is nothing but multiprocessing. So you all should know the difference between multiprocessing and multi-programming. Okay, so going ahead with our process management. So now we have processes, number of processes which are there in the memory waiting for the CPU, so that CPU can execute. So what is the process management function of the operating system? Right? So what does it tell you? Process management function tells you basically that out of the many processes, which process will the CPU execute and for how long? So these are the functions, process management functions of the operating system. So the process management function says it should ensure that each process gets a fair share of CPU's time. It's not only one process that is actually taking the CPU time. It should be divided fairly among the multiple processes which are there in the main memory. And the operating system must also determine when the CPU can be made available to the process and for how long. So once the process controls the CPU, once the CPU has been allocated to a process, means what? The set of instructions pertaining to the process are executed until its time slot expires, assuming that there is a certain time slot allotted to each process, or it terminates voluntarily, it has finished execution, or until it requests an IO operation. So the last statement is very, very important, students. I'll again repeat. Once the CPU has been allocated to a process, right, there are a number of possibilities that can happen. One is that either the time slot allocated to the process expires, so in that case the CPU is taken away from the process. The other option could be that it is terminated. That means it has finished execution and it voluntarily releases the CPU. Or the third is that it could request an IO operation. And the last one means what? What is the meaning of it could request an IO operation? Any guesses, students?
Attach keyboard or doing some printing operation.
Right. So for example, when a program executes, any program that you take, you must have written n number of programs, right? So whenever a program executes, you always have, first we start the program execution, and then you have certain statements where maybe you require some input from the user, you have some output statements, then you have some processing. So we see that whenever a program executes, it moves between two cycles. What are the two type cycles? CPU cycle, IO cycle. Then CPU, IO, and so on. What is the meaning of IO cycle and what is the meaning of CPU cycle? What is an IO cycle? Which set of instructions are coming under IO cycle? Yes, Amok, are you there? Amok Shanbag?
Yes, ma'am.
Yes. So tell me, which
Maybe the input and output commands, like when you have to like press print, or when you have to print something, or when you have to input a keyboard or something.
Okay, right. So when you require some information, you require some input from the user, you need to like display some output. So this is nothing but where the IO device is required. So we say it's an IO cycle, where there is some sort of processing that is going on. For example, some computation like A is equal to A plus B, or some some looping and some going on. That is nothing but your CPU cycle. So I'll give you an example here in the next slide. So whenever a program executes, it executes as a sequence of CPU, IO, and so on. It either could be called as CPU burst, IO burst, or CPU cycle, IO cycle. So let's take this example. So when you say start, whenever a program starts, see this basically a program I've written, I've not tied down to any programming language. It's just an algorithm which could be translated to any programming language. So when you start, it always starts with a CPU cycle. For example here, read A comma B. So read A comma B means what? Now input-output devices are required. Input device is required, where the values of A and B have to be read. So that is nothing but IO cycle. Then consider C is equal to A plus B. C is equal to whatever, some sort of processing, that comes as a part of CPU cycle. Next, if you have write the values A, B, C, D, E. Here you require some display device to actually write the information. So that becomes an IO cycle. And finally, you have stop, which is nothing but the CPU cycle. So again, I repeat, whenever a program executes, it always goes back and forth between a CPU cycle, then IO, then CPU, and so on.
Yep.
But what you have to remember is always it starts and ends with a CPU cycle, where the CPU is required.
Of course.
Is this clear,
Starter
students?
end तो CPU करेगा.
Any doubts, any queries here?
और read या operations जो करने होंगे CPU.
So, we come to another topic here. This is again one very important topic. You have always a question on this. That is called as what is the states? What are different process states and what's a process state transition diagram? So what is the meaning of process state? So we say that as a process executes, right, from the time it is there in the secondary memory to it terminates execution, if we say that it changes state, it moves from one state to the other, right? So then we have a number of states. We have a 5-state process transition diagram. As of now, I'm teaching you all 5, then we'll move ahead a more refined diagram, which is nothing but a 7-state. So let's see what is a 5-state process transition diagram. So coming to the first one. So what do you think is the first state? From whatever I have taught you all so far in last 5-10 minutes, you should be able to tell me that
I'm loading a program into main memory. That should be the first state.
But when it is there in the main memory, when it is there in the secondary memory, the program is there in the secondary memory, that is also a state. Right? So basically first we start with considering that there is a program which is there in the secondary memory. What will happen after that? Once it is there in the secondary memory?
It will be loaded in primary.
Loaded into main memory.
Yes, it is loaded into the main memory. Okay. Just let's see the sequence and then we will convert it into states. After it's loaded into the main memory, what should happen next? It is waiting. It is waiting for what?
It's turned to get the CPU.
Yes.
Execution for the CPU time.
Right. So basically it is waiting to get the CPU. So then maybe its turn comes and then it gets the CPU. So that's again one state. Then after it is working for some time in CPU, then it might go to which state? It might go transition or wait for what?
IO response.
IO,
IO
yes.
response.
Yes, IO devices. It could wait. It could need some IO devices because of which it cannot proceed, so it has to wait. Once it gets the IO, then it again goes back to the execution. But when it goes back to execution, it will not directly, it has to again wait for its turn to get the CPU. So in short, this is the way in which the program execution happens. So let's see the states. Now let's convert the entire thing, whatever we have seen, into states. So we have here, as the process executes, it changes state. So we have each process may be in one of the following states. So first, let's say the new state. What is a new state? A new process has not yet been loaded into the memory, although its PCB, process control block, has been created. At this stage, you won't understand what is PCB. I will take in detail after a couple of lectures. But what you should know is, pertaining to every process, there is a data structure. We call it as a process control block. That data structure is storing information. What information? That we will see later. Some information about process. So there is a one-to-one relationship between a process and its PCB, a process control block. So first we have a new state. What is a new state? A process has not yet been loaded into the memory. That means it is where? Where is it?
ROM.
No, not in ROM. ROM, so you have BIOS programs. It is
Secondary memory.
It is a secondary memory. Yes, it is in the secondary memory. So that is nothing but the new state. Okay. Then afterwards you have a ready state. So what is ready state? Yes, what is ready state? Any
It is
guesses?
ready to execute and waiting for
Ready. It is ready for
Waiting
it is
for
ready to
CPU
execute and waiting for CPU time.
CPU. Right. That means where it is, but in ready state, where is it
main
located?
memory.
Main
Yeah,
memory.
the main. So that's nothing but the ready state. The process is in the memory. When I say memory, please students, you have to remember it's main memory. The process is in the main memory and waiting to be assigned to a processor. That is nothing but the ready state. The process is ready now. Okay, coming to the next state. Next state is nothing but a running state. Any guesses what is the running state? As the name suggests?
The process is now starting.
Right. So that means the processor has been assigned and now it is executing. That's nothing but a running state. The process that is currently being executed, assume we have a computer with a single processor so that at most one process can be in this state. So this is what I told you all a few minutes back. That when you have a single processor system, at a time only one process can be in the running state. How many processes can be in the ready state?
That depends on degree of multi-programming.
Yeah, very good. That depends, but there can be many. There can be many processes in the ready state, but if I am talking of a single processor system, there has to be only one process in the running state. Okay, after running, the next comes waiting state. What is waiting state?
Waiting for
The
IO.
process that the
Waiting for the
execution
IO.
of the process is suspended.
Yes, right. So the waiting means, that means now it has finished how much of a CPU data to execute. Now it is waiting for some IO device. So that is nothing but the waiting state. So the process is waiting for some event like IO. That means it is waiting for some information. It is waiting to be assigned an IO device. It is waiting for some information from the input-output device. That's the other name is also called as a block state. And the last one. The last one is terminated. The process finishes execution. We say it is in the terminated state. So now, remember this, there are 5 states: new state, ready, running, waiting and terminated. Right? So again the last statement says that only one process can be in a running state, but many processes can be in the ready and waiting state. Any doubts in the states? The transition diagram we will see in the next slide. Students, am I going fast? If so, please tell me now. Am I going fast, students?
No, ma'am.
Okay. So any queries, any doubts in these states? New, ready, running, waiting, terminated?
Ma'am,
Your
can a
queries
process
for the
be
number-
under execution? Ma'am,
Yes.
can a process be under execution while another process is in the waiting state?
Yeah. That's what many processes can be waiting. Acha, waiting means waiting for IO devices. Yes. Not the same process. If a process is in the block state or the waiting state, some other process can be in the running state.
Okay, ma'am.
But at a time, a process can be only in one state. Remember that. Okay. So now coming to the state transition diagram. So process state transition diagram, basically how do you draw a diagram which relates all these states? From which state you move to the next state and so on. Okay. So tell me, your start. You will tell me which is the transition. First state to the second state. What are the two states which is coming first into picture?
New and ready.
New ready.
So there will be first, the diagram will consist of a state new. From new there will be an arrow to ready. When it is ready means what? When it is moving from new to ready means what? It is admitted. The process is admitted where?
Main memory.
Into the main memory. Yes, into the main memory. Okay. Now it is in the ready state. Right? From ready state, it is going to transit to which state?
Running state.
Running.
Yes, running
state.
state. That means the CPU is assigned, it is dispatched the CPU, the process has been dispatched the CPU, and now it is moving from ready to running. Okay. So now we have seen two arrows up till now, from new to ready and then going from ready to running. Okay. Now from running, what are the possibilities?
Terminate or wait.
Either it will get executed or wait.
No. If it is in the running state. It is in the running state currently. From running, it can move from which state? From,
Ma'am, if its execution is completed, it will be terminated, or if it's required any IO device, it will go to waiting state.
Wait.
Perfect, right? So what he said is right, but there is some more to it, one more point to it. So what he's saying is that from running, it has finished execution, it goes to terminate state, or it goes to exit state. Now either then, otherwise it might require some IO device. So from running, it will either go to the blocked or the waiting state. Is this much clear, students?
Yes, ma'am.
Yes, ma'am. Now there is one more option. There is one more possibility. From running, it can move to ready state. Tell me some circumstances where it can move from running to ready state.
Ma'am, if there is a specific execution time and the process has taken that time.
Yes. So for example, if the CPU, if it is said that the CPU will be allocated for so and so time, and if it is about to exceed that time, right, the time allotted to be executed on the CPU expires. So in that case, what happens? It is moved from running to
ready
it
state.
has not complete. It goes from running to ready state. See, again I repeat. Once the CPU has been executing, it is in the running state. From running, what are the possibilities? One possibility is that it finishes execution. So it goes to the terminate state or the exit state. The second is that it requires an IO device. So for that, it will move from the running state to the block state, also called as the waiting state. And the third option is what? From running, suppose the time allocated to that process expires, that this much only time you can execute on the CPU. Now it's over. So it moves from your running state to the ready state. Okay, so there are three arrows which could be possibilities. From running, it could move to all these states. Okay, this is fine. If it is in the block state, from block state, it can move to which state?
To running state.
Directly running? It has to
First ready, then running. First ready, then running.
Ready and then run.
Yes, so that means it has to move from block. Suppose that whatever input it was waiting for, whatever output in our device it was waiting for, it has got. That means it moves from the block state to the ready state. Again, it has to wait for its turn to get the CPU, and then again it moves to the running state. So we'll see the diagram in detail. Is the diagram visible, students? Is the diagram visible?
Yes, ma'am.
Right. So the same thing, whatever I explained, from new, go to ready state where it is admitted for processing. From ready, it will go to running state when it gets the CPU, when the CPU is dispatched. That's why the arrow has been named as dispatched. Then from running, either it finishes execution, it releases the CPU, it goes directly to the exit state or the terminate state. or from running, it can go to the blocked state where it is waiting for an IO device, or from running, if it's a timeout, it goes back to the ready state. So these are the three possibilities which I was explaining here. And from the blocked, if the event occurs, if it has got the IO device, it goes back to the ready state and then the cycle continues. Is this clear, student? Is the diagram clear?
Yes, ma'am.
Yes, ma'am.
So you have to remember this process state transition diagram, students. And this is a 5 state. In the next class, maybe tomorrow, I will start with the 7 state also. That's also very simple. Now coming to process queues. Once the transition diagram is clear, we will see another topic which is nothing but queues. What are different queues which are maintained by the operating system? So what happens here? The OS keeps track of processes with a set of queues. So you have actually 3 queues. One is nothing but a job queue, a ready queue, and a device queue. Again, I repeat, a job queue, ready queue, and a device queue. First of all, tell me what's a job queue? See, it's a queue. Basically, it has processes. It's a queue of processes. So first of all, there'll be job. When I say job, where is it? Where is that queue maintained? Yes? Come on. Okay, if I say a program queue, means what? Where is it? Where is that queue?
Secondary memory.
Yes.
Secondary memory.
Right. So job queue is basically a set of all processes in the system, but it is where? It is nothing but in the secondary memory. So basically you can say it is a set of all jobs, set of all programs which are waiting to get where?
To CPU.
Yeah, but before CPU it has to get where?
In main memory.
Yes, a set of all processes which are waiting to get into the main memory. That's nothing but a job queue. Okay. Coming to the ready queue. What do you think is a ready queue? A queue of all processes?
Waiting to get
That are ready to be
Waiting to be
assigned to the
executed.
CPU.
Yes, set of all processes which are waiting to get the CPU. But where is it? Residing where?
main memory.
Main memory.
Main memory.
Very good. So ready queue. A set of all processes residing in the main memory, ready and waiting to execute. So that is the ready queue. And finally you have a device queue. What's a device queue?
Set of processes which are waiting for IO devices.
IO devices. Yes, so as the name says, set of all processes waiting for the IO devices. But the question is whether there is only one device queue or there are multiple device queues depending on. First of all, tell me, is there only one IO device in the entire system or there are multiple IO devices?
Multiple.
Multiple.
So each device will have its own.
Queue.
Device queues.
Yes, each device will have its own device queue. Remember, only one job queue, only one ready queue, but multiple
Device queues.
device queues. Right? That depends on how many devices are there. Set of all processes waiting for an IO device. So that's nothing but device queues. So we have processes migrate between the various queues as they execute. So we have seen the state transition diagram. You know what are the queues? There are the queues. So as and when processes move states, basically they migrate. They move from one queue to the other. Is all this clear, students? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So I'll just take one more topic and then I will stop and I'll go to the test. So that one topic is nothing but what are different schedulers. Schedulers which are there as part of the operating system. So what happens is, what's a scheduler? Basically when it's a software, it's a component of the operating system. But what is it doing? For example, if there are processes which are there in the secondary memory, right? What are the there are as of now, I'll explain you two schedulers. One is nothing but long-term scheduler and short-term scheduler. So what is the long-term scheduler? The other name for long-term scheduler is also called as a job scheduler. What is job scheduler doing? When you have processes in the secondary memory, it selects processes based on some criteria from the secondary memory and loads them where?
Main memory.
In main
Loads them
memory.
in
Memory.
Right. So that is nothing but the long-term scheduler. What is the job of the long-term scheduler? To select processes from the secondary memory and put it into the main memory. So that is LTS, long-term scheduler, also called as the job scheduler. Coming to the next one, that is nothing but the STS, short-term scheduler. The other term for short-term scheduler is nothing but a CPU scheduler. So any guesses what is the CPU scheduler doing?